All right, so in example 4, we have to evaluate here a couple of things. It looks crazy. It looks like this is a ton of work. It's not nearly as bad as you think it is. Okay? Remember what this notation means. This means the sine of 45, whatever it is, and then you're just going to square that. So if I look at what the sine of 45 is, or figure it out on my hand if you're feeling adventurous, right? Square root of 2 over 2. I'm just going to take that and square it. That's what that notation means. So square root of 2 over 2, and I'm going to square that. That's what that whole chunk means. This is this. Then this piece, I kind of do the same thing. It's going to be 3 times whatever the cosine of 135 is squared. All right, cosine of 135. Let's talk about that. I don't know what that is. So let's find its reference angle. 135 degrees is over here. So this angle's got to be 45. So this is really 3, it's equivalent to 3 times the cosine squared of 45, but I do have to take the sine into account. What will the cosine be in this quadrant? Am I positive or negative? Negative. So instead of that, since this is going to be negative, I'm going to turn this into a minus right there. So now let's look at what the cosine of 45 is. Oh, wait. I don't think I can do what I just did. I made a boo-boo. You can't just put it there because I have to square it first. So what happens when I square a negative? It turns into a positive, so I shouldn't have done that yet. Okay, what I do need to do is look at what the cosine of 45 is, root 2 over 2. So I'm going to do 3 times root 2 over 2. It is negative, but I'm going to square it. So it's going to come out positive anyway. And then I have this piece here, minus 2 times the tangent of 225. Okay, let's think about 225. That's somewhere over here. That would be my reference angle. So that angle's got to be 45 again, right? If that whole thing is 225, let's take 180 out of it. I'm left with 45. So tangent, all students take calc. I am positive down here, so I don't have to worry about it. So tangent of 45, and tangent of 45 is 1. All right, so now I need to evaluate. Root 2 over 2 squared. If I square the, excuse me, I have to square the top and square the bottom. So what is square root of 2 squared? 2 over, what's 2 squared? 4. So I really get a half right there, don't I? So let me actually just make that a half. So that's a half. Plus, now I need 3 times this thing. Well, I just squared that and I got a half. So 3 times a half, isn't that 3 halves? Minus 2 times 1 is just 2. So 1 half plus 3 halves is 4 halves, and 4 halves is just 2, and 2 minus 2 is 0. That's my final answer for this one. They look terrible, but if you just do each piece, it's really like 3 mini problems in one. Okay, one last problem. You ready? All right. So this one says, find all values of theta if theta is in the interval from 0 to 360 and sine is equal to negative root 3 over 2. What? All this is saying is kind of working the other way around. Instead of me saying, hey, what's sine of 45 degrees? It's saying, hey, here's a random sine value. Tell me every angle that has that sine value. That's basically what they're doing. Okay? This interval from 0 to 360 just means I'm dealing with the whole circle. So out of all 4 quadrants, who will have a sine of negative root 3 over 2? So how do we do this? First of all, let's figure out what quadrants I can even be in. If I'm going to have a sine that's negative, there's my 4 quadrants. Who has, where can't it be? It can't be in quadrant 1, because everybody's positive there. Where else can it not be? 2, right? Because this is the other one where all students, so this is the one. So I'm looking for angles down here. These are the only 2 that would have negative signs. Okay, so now I also want to look, all right, well, who has a sine of root 3 over 2? Well, let's see. Sine root 3 over 2. Oh, by gosh, it's 60. 60 degrees would have a sine of root 3 over 2, right? But I can't have 60 because that's in the first quadrant. So basically, I need to figure out what are the angles that would have a reference angle of 60. So check it out. I'm going to have some angle that's here where this is 60. Does that make sense? Everybody with me so far? So what must this angle be that starts here and goes all the way around to here? 240. Do you see that? Because it's all 180 plus 60 more. So that means if theta were 240 degrees, it would have a sine of negative root 3 over 2. Now that's not the only one though. There's someone over here. So if I drew my triangle in this quadrant, so if it landed here and I drew my perpendicular up to the x-axis and this was 60, well, what angle is that? So that angle would have to start here and go all the way around to here. Who is that? 300. Correct. So my answer in this case is 2 numbers. 240 degrees and 300 degrees. Does that kind of make sense? So you would just have to see, well, I start off with the sine and then I figure out what quadrants are even in the running. And then I'm like, all right, then who has whatever the value is, if it's sine, cosine, tangent, whatever. So in this case it was sine of root 3 over 2. 60 is the only one that has that. So then I just figure out, well, who would have a reference angle of 60 in each of those quadrants? Yep. Well, this table is on your reference sheet. The only thing that it doesn't have the reciprocals. So, but it has sine, cosine, tangent. So as long as you know to take the reciprocals to get the others, then you have the whole chart as on your reference sheet. But you always have your left hand where you can figure it out if you want it. What fun. Okay. I think that's it for 2-2. So I do have a little activity for you. Let's stop this video here.